Now we start with the question of if we have a normal vector AI plus BJ to this segment here, then what's the ratio of the length of the segment to the delta x that you have down here? Well, we can see that delta x is going to be this side of this orange triangle. And we can also see that we could project the normal vector onto the k vector, the vector in the z direction, and we get another triangle that's geometrically similar to this one. Okay, the delta x, well, there's a geometric argument for this. I don't want to get into it because I'm afraid that I'll lose people with that argument. It's a really low-level argument, but don't want to confuse things. So maybe I'm avoiding clarifying it. I don't know. The way I pose the question is now, here's your normal vector. What's the slope of the normal vector? Well, it's rise divided by run, j component divided by I component, b over a. So what's the slope here? Well, this is perpendicular to this. So the slope is, in the case as I've drawn it here, with both a and b positive, slope is negative, so it's going to be negative b over a. Sorry, I think I said it wrong. Negative a over b. Okay, and of course I wrote it down correctly here. Why is this? Well, from Algebra 1, Algebra 2, pre-calculus. You know that the slope of the slopes of two lines that are perpendicular, or the slopes of two vectors that are perpendicular, are negative reciprocals of one another. So if the slope of this, as it has to be, is b over a, the slope of this is negative a over b. So this segment is going to have length 1 plus the square of the slope times delta x, just using this idea and expanding on this idea. Okay? And that would be, well, if your normal vector, if you have a section of some curve up here or some surface, your normal vector to the surface would be fxi plus fyj, the gradient of whatever that is a level curve of. Okay, so if it's f of xy equals constant, then here's your gradient, and that's the direction of your normal, which means then that this would be the square root of 1 over fx over xy, fx over fy quantity squared multiplied by delta x. So this is another way to find the multiplier of this length here to get this length. You multiply this length by this factor, you get this length. Okay, now there's even a better way to do that using dot products. So I'll talk about that next.